Major funding for Saving Our Waters is provided by Vermont EPSCoR, funded by the National Science Foundation, supporting science, technology, engineering, and math in Vermont colleges and businesses, and encouraging young Vermonters to seek careers in science. Additional funding provided by and from viewers like you. Thank you.
Lake Champlain is really a jewel here in Vermont. People come here because we have green mountains and blue waters, and they'd like to partake of those.
No one wants a dirty Lake Champlain. The reality is that we have a dirty Lake Champlain. When we see the level of cyanobacteria outbreaks, that is a very well observable symptom of a huge problem.
In the late 1990s, we first saw algae blooms, cyanobacteria blooms here in the lake. A couple of dogs unfortunately died, and that's what really brought these blooms into the headlines and to the attention of people. And they have since become, unfortunately, regular occurrences during the summer months here on Lake Champlain.
The issue with it is sometimes it can turn toxic. That creates a public health threat.
The greatest water quality challenges we face here in Vermont are largely attributed to nutrient pollution. Phosphorus and nitrogen are nutrients that are essential for plant growth, but when they are in a surface water body in excess, that can take the form of harmful algal blooms.
There are three things really that drive an algae bloom: food, nutrients, phosphorus, calm water, and warm water.
So an important linkage that we've learned that's been critical to understanding algal blooms in the shallow bays of Lake Champlain has been the role of these particles that come in from the watershed and are deposited into the lake. We were able to develop a really comprehensive picture of the weather and the lake conditions that facilitated the release of phosphorus from the sediment pools.
One of the reasons we're seeing an increase in cyanobacteria blooms on Lake Champlain is because of climate change. On Lake Champlain, since we've been taking temperature profiles in the early 1960s, we've seen an average August surface temperature increase by 6.8 degrees Fahrenheit. That's a significant ecological change.
When we have these warm, hot, sunny summer days, especially after a big storm has blown a bunch of sediment with phosphorus in it and loaded up the lake with phosphorus, that's a good recipe for an algae bloom.
We cannot just simply go in and clean the sediment from the lake and say that we've taken care of the problem. So I think there are these lags and inertia in the systems that people will need to think not only for their lifetimes, but also think long-term, multiple lifetimes.
Extreme weather events is the focus of this new research project, understanding what within the Lake Champlain Basin essentially promotes or suppresses that resiliency of water quality during these extreme events. And those could be extreme droughts, those could be extreme storms.
So some of our work in the Missisquoi, for example, is telling us that even if we reduce like 50 to 70, 80% phosphorus, it's going to take 20 to 30 years for the algal blooms to go away in the months of June and July. The way these natural systems behave, they're not necessarily connected with each other in a linear fashion. So, for example, what is known as legacy phosphorus in Missisquoi Bay, but also in other parts of the lake, the phosphorus that was put in the lake in the late 19th century agricultural boom in the state of Vermont, that phosphorus is still in the sediments. And the sediments may release that phosphorus when the conditions change and they become very hot, or there are other biological conditions that basically may enable the release of those sediment-bound phosphorus. And the phosphorus that we are putting in today on continuous basis might become unbound 50 years from today or 100 years from today.
Although cleaning up Lake Champlain will take time, it is possible. Phosphorus reduction is key. Phosphorus bonds naturally with sediments in water, so it travels easily from our smallest creeks to Lake Champlain. Recent studies have identified the principal sources of phosphorus as stormwater, wastewater, erosion from roads, agriculture, and runoff from some forestry practices. Research that integrates the many factors leading to excess phosphorus in water now informs long-term best management practices in this complex system.
People like to think that folks who live in the cities aren't part of the problem. They like to point to the farmers and other things that may be going on in the watershed as being a bigger problem. But the reality is that runoff from impervious surfaces can contribute as much or more per acre than farm practices when we're talking about phosphorus.
As we see more significant rainfall events, more extreme weather events with greater intensities of rainfall, we see more runoff. And we know that the total phosphorus pollution delivered to Lake Champlain in any given year is very closely tied to the amount of rainfall we receive.
The major challenge with stormwater runoff is not the stormwater, not the stuff that falls from the sky. It's the fact that we've covered our landscape with impervious surfaces, which disrupts the natural hydrologic cycle. Water likes to soak in and then travel slowly to water bodies via groundwater.
Water trapped on impervious surfaces, like pavement, can carry phosphorus quickly into our waterways. This stormwater runoff has become more problematic as we experience increased and more intense storms. Finding effective solutions is forcing us to look at past and present development and infrastructure.
Particularly in the case of Burlington, where we don't have a lot of open green spaces, our approach is a little bit different than, say, a more suburban area where you might be able to bring all of the water for stormwater treatment to one area and do a large practice like the gravel wetland that we have at the skate park or a retention pond. In Burlington, we have to try to use all of the little sponges that are left and potentially the sponge that may remain underneath our impermeable surfaces. Even though it's raining, I'm going to make it rain a little bit harder. And the idea behind this is that even though I'm going to pour a ton of water on here, it actually soaks in. And that's what we're looking for. We're trying to create a surface that people can park on and walk on easily in an urban environment, but that it's not going to have the runoff that we see with other asphalt in the rest of the city.
Phosphorus runoff also comes from our homes, from lawn fertilizer and pet waste, from gutters draining to impervious driveways that flush water into the road. Phosphorus and dangerous eroding runoff can be reduced if water is allowed to soak into the ground before reaching the road and overloading culverts and drains.
One of the requirements of the new permit in order to meet the Lake Champlain phosphorus TMDL is going to be for us to develop a phosphorus control plan to reduce the amount of phosphorus running off of Burlington's landscape by, I think, as much as 20%, which is a heavy lift that will take us a number of years and a great deal of money to do. Every little bit helps. If 10 homes band together and do something to maintain the water, keep the water on their own property, that is just as good as a parking lot that has installed a detention pond to manage that water. So it is a game of inches at this point. We don't have a large field that we can send things to. We need everybody to hold on to as much as they can with every little bit of green sponge we have left in the city.
There are many ways individuals can reduce runoff leaving their properties by installing rain barrels, porous driveways, and disconnecting gutters. Small cities and towns are also coming up with plans adopting best management practices. St. Albans was designated an MS4 community in 2012, meaning they will have a new set of regulations for their stormwater collection that is separated from wastewater.
We're in the infant stages of trying to figure out how to improve water quality based on that designation, which really meant to us we no longer could just think about how to improve our water quality issues, but that we had to come up with some tangible plan. The practices of the last, say, 3 to 5 decades have proven to be harmful, so we need to change them.
A retention pond is our large container to hold that stormwater from this neighborhood for a desired period of time, and usually it's about 24 hours. So if we can meter that flow and release that water at a nice gentle rate and prevent, bad things from happening downstream and erosion, which is probably the worst thing that could happen.
These are sort of the things that need to be done, but they're fairly boring. And so making sure that people are aware that that's not just a ditch, that we've actually installed a practice in it intended to reduce pollution is really important in helping them see the work on the landscape. because that will be visible far before we see the benefits of those projects materialize in our rivers and lakes and streams.
Examining the behavior of the entire watershed, Vermont scientists working in the EPSCoR Basin Resilience to Extreme Events project continue to research the entire landscape, the social and ecological system, sensitive to change brought about by our decisions now, in the past, and in the future.
So the component parts of the integrated assessment model include a climate model that's projecting the future alternative states of the climate going out 100 years, given different wet scenarios, dry scenarios. Another key component is the hydrology model that is modeling and simulating the flow of water. The other dimension is the land use model, and we're able to then project what future scenarios would look like. What would a pro-agriculture scenario, what would a massive population explosion look like? And that is connected to the lake model. And all of those wrap together to anticipate and predict how the algae blooms will affect. Now with BRE, 2 additional elements of the model are being added: a governance model that's looking at different policy scenarios and strategic resources and investments, as well as an economic model that really looks at the economic consequences of doing nothing or of doing everything we possibly can and every variation therein.
Erosion from our paved and unpaved roads is a significant source of phosphorus to our lakes. All Vermont towns are now reviewing their roads to meet new Act 64 standards put in place to control runoff of sediment.
So in recent years, we've learned that municipal roads can be a really significant source of phosphorus and sediment pollution. And it's an important recognition because we have literally more than 8,000 miles of roads here in Vermont. I think upwards of 85% of them are gravel. And so the opportunity for them to shed sediment and phosphorus in any given rain event is significant. Through research done here at UVM, we've looked at a suite of best management practices that can be deployed by municipal road crews to start to control that erosion and sediment loss.
With Act 64 and the MRGP, the Municipal Roads General Permit, we focus more on the hydrologically connected segments of roads. So the roads that are closer to the streams and closer to the, the cross culverts and stuff like that.
That's not bad. I just think we have to lower that shoulder. So towns will be required to do an inventory of their roads to see if the practices necessary to address water quality are in place.
As more and more of these roads get up to speed with the new practices, I feel that it's just going to save us in maintenance, in the long run.
And the towns are more flood resilient as we have more rain events. When these drainage practices are put in place, those roads are less likely to fail catastrophically. And with that, all of the sediment into our streams and all of those millions of dollars in damages that we've been experiencing the last few years.
The new municipal permitting program prioritizes roads that are near rivers because rivers are constantly moving and a significant source of erosion. Learning more about where that erosion occurs in rivers and how best to minimize it is critical.
My first day of class was the day Tropical Storm Irene impacted Vermont, so that was really a big driver in refocusing my attention on water quality issues here. We're using unmanned aircraft systems, UAVs, to look at mapping stream bank erosion. And we care about stream bank erosion because that's one of the primary sources of sediment moving out of a lot of watersheds in Vermont. Being able to monitor a river corridor in a timely way with a UAV can add a lot of value to really getting an understanding of the kind of rates and timing of when stream bank erosion is taking place and also where. And we're able to generate basically 3D topographical models of the river corridor and compare those over time. And so what our models show us now is we can basically look at a cross section of the river, and off of those we can measure the amount of bank retreat that has occurred, as well as calculate the amount of erosion that's happened. This will give us another tool that'll be able to respond quicker in terms of monitoring for stream bank erosion, and also being able to get a better estimate as we go forward and start implementing practices to reduce stream bank erosion if we're being successful with that.
Research has also made clear that supporting and preserving wetlands and vegetated stream banks can help reduce erosion that delivers sediment to lakes, especially as we have larger and more intense rain events.
One of the big sources of phosphorus is erosion from stream banks, where the stream banks are just, the streams are moving back and forth as streams will do because we've constrained them over time. We're giving them room. The state is buying lands adjacent to the stream so that they can meander without eroding as much.
The different types of wetlands that are dotted across the landscape really play an important role, and they can help kind of handle different types of water that runs off of the surface when it comes to large storm events or flooding events, especially along riverways. Wetlands can play an important role in helping to be able to absorb water or even release water in times of dryness. So as we see increases in pollution across our landscape, if we keep wetlands in place and intact, those are places that can help filter the water just by the different plants that are there.
Riparian zones are really the interface between what's happening in the soil and what's happening in the stream. They are very dynamic environments. That's really the near stream areas that are vegetated. We call them hotspots. Which just really acknowledges that whatever is going on in the landscape, it doesn't happen at equal rates everywhere. There are places in the landscape that probably because there is water and nutrients accumulate and carbon accumulates, they're really the sweet spots for reactivity. So our hypothesis really is that these riparian zones, these riparian buffers, are instrumental in building resilience, so really being able to absorb water quality issues after extreme events, much better than if you have a system without riparian areas.
Although clearly there are many contributors to phosphorus reaching our lakes in Vermont, the largest contributor is from agriculture. To continue the work of farmers, scientists, and the state together, Act 64 has put into place many best management practices.
I think some of the most encouraging work is frankly on Vermont's farms. Farmers, I know, take pride in the fact that they are some of the original conservationists and stewards of our land. And there's been a significant number of farmers that have really risen to the challenge of implementing practices to mitigate phosphorus pollution and improve water quality.
Farmers have a huge stake in protecting water quality. They need to protect their water so that their animals have clean water, so that their families have clean water, but then this added piece so that their communities have clean water too.
Water quality is important to every farmer, and we all are very aware of the fact that our cows drink a lot of water in order to make that milk, and water is just a vital part of all of agriculture.
Actually, most of water quality problems is erosion. It's dirt leaving the field that gets into the stream, that heads to the lake, carries a lot of nutrients. So to prevent the topsoil from leaving is why we do the things we do.
Agricultural best management practices tend to be some of our most cost-effective opportunities to further address phosphorus pollution. Just as wastewater was really a cost-effective place to start, agriculture is the cost-effective place to move best. It is far easier and cheaper, frankly, to implement conservation practices on farms than to retrofit stormwater devices in a built urban environment.
So what we're finding is really it's about the system. It's not just one practice, right? It's a whole suite of practices. So it's good manure management, it's having a living growing plant 12 months a year, and it's having the right equipment as another really important piece, and having good crop rotation and nutrient management. And that's where all of that sort of has come together in soil health and good crop production and good water quality.
Vermont farms are now required to have a nutrient management plan to track and reduce runoff through a variety of methods. The transition to new practices is not easy and without cost, but results are showing these new practices are paying off, not only for our communities' lakes and streams, but also for the farmers.
Yeah, I mean, farmers are in a difficult situation. They have a business, and they have to be able to make a profit on that business, or else they're going to go out of business. At the same time, there are broader environmental interests at work, and I think that the vast majority of farmers understand that and appreciate that. And what we're trying to do in our whole research project is figure out what the right balance is. So the ideal of adaptive management is that we use science to inform public policies. And so a big component of our work is collaborating with stakeholders and policymakers and farmers. I think our broader goal here is to help inform how we might preserve Lake Champlain and water quality in Vermont as we move forward with a changing climate, as potential for our population to grow. We need to better understand how all these complex systems dynamics combine and commingle so that we are able, at least my hope is that we can better plan and better design our social and our ecological systems so that we can preserve Lake Champlain for future generations.
Buffer strips on the dairy farm is mandated by the state. Our nutrient management planner will come in, check the field maps out, and anywhere where there should be a buffer strip and wherever he thinks there should be one. That way there, when the state comes to check things out, we're covered, and it's just grass strips in between the ditch and the cornfield, bonding the soil together with roots so the nutrients and erosion don't take place.
As a part of Act 64, all Vermont farmers who spread manure complete training on best application practices. Another way some farmers nourish the soil and keep their streams near fields clean is with a practice called manure injection, which buries the manure on their fields up to 12 inches in the ground. Farmers pipe the manure from the farm to a tractor in the field, which injects the manure under the ground.
So if you can get that manure under the surface, then you're going to have far less likelihood of it running off, say if you have a rainstorm. So if you have healthy, high-functioning soil, you have healthy crops growing, but you also then are protecting the environment, reducing runoff. All of that kind of comes together around soil health. So the way that typically we've worked here in the Champlain Valley is a lot of what we call fall plowing. They would actually plow their soil in the fall and let the winter really do some tillage for them. And so now we're transitioning away from that fall plowing system because we see the potential of those months and months of the year of bare soil open it up to losses, to erosion, and if you've spread manure in the fall, you're going to have some of those nutrients just lost to the environment because there's nothing there to take it up. So now we're asking farmers to, instead of that, plant a cover crop over the winter.
The adoption of cover crops in Vermont has been extremely rapid over the last couple of years.
These cover crops, the root systems that they provide in the soil, are actually doing the tillage work themselves, and the worms will travel up and down these root systems, and it allows the water to infiltrate down into the soils instead of running off the tops.
The field we're in today, the farmer planted the winter rye, and then this spring, it survives the winter, it grows. They actually harvested that cover crop as a forage crop to feed their cows, and then came in right after and planted without tilling anything and just planted their corn. And that's what we see, growing here today. It's not the easiest thing to grow corn in Vermont. And farmers have really figured out how to do it. And so now we're saying, oh wait, let's try it this way and mix everything up. So there's a lot of risk involved anytime you plant a crop. And when farmers have really figured out a system that works on their farm, it's really hard to make that change when you don't know if it's going to work or not. So what we're seeing is farmers try it in little bits and pieces, and then as they figure it out, we see them adopt it on larger and larger scales. We also see, say, a neighbor try something, have it work, and have the other neighbor see that and be like, okay, well, maybe I will try that.
It's really exciting as the snow melts in the spring to not see exposed soil, but to see green grass that literally takes off the instant it's given the chance. And in the 12 years I've been working on water quality projects here in Vermont, we've gone from a time when there was literally maybe 1,000 or a couple thousand acres planted to tens of thousands of acres now being planted in cover crop. And I think that's a really exciting change.
All agree that farms are precious to Vermont, but conventional dairy farming is expensive in many ways. A difficult discussion is taking place about how our working lands and farmers can thrive in conjunction with keeping our waters clean. Trade-offs we face will continue to be clarified and discussed for some time.
The regulations are a good step, but it's basically imposing a regulatory regime over the way the land has been farmed and used, for generations. It's not really a sea change. It's not a paradigm shift. So I think, how do we have a paradigm shift that doesn't leave farmers in the dust, that doesn't put them out of business and bankrupt them? And how do we make sure we have working lands? We want working lands. We don't want that land to be developed. We want it to stay productive, but this is a multi-generational problem of the way we've been using the land has had these impacts, and we really need to almost rethink everything about how farming occurs. It's a really difficult conversation to have. It's a really difficult policy issue, but I don't think it can't be ignored. If we really want to get where we need to go, we've got to try to crack this, and we got to stop looking at it like the environmentalists versus the farmers or anything like that. We're all in this together. We want the farms to be successful. We know how hard this is for farmers and the changing that's happening, but we have to just be honest with each other about kind of where we need to go.
The Vermont Clean Water Act lays the groundwork for important, powerful steps towards saving our waters, but it is expensive and will take time to implement. While that work is ongoing, scientists are also studying what makes a lake resilient during storms. Resilience throughout the watershed poses a great challenge and opportunity for the future of clean water that can withstand extreme events throughout the landscape.
The only way we're going to get to the water quality outcome that I believe all Vermonters want is by all of us actively engaging in this work. It doesn't matter if you're a residential homeowner, a commercial property owner, a farmer, a municipal road crew. Everybody has an important role to play, and by using the tagline "All In," we're pushing people to think about their role, not the role that they think their neighbor should have.
Major funding for Saving Our Waters is provided by Vermont EPSCoR, funded by the National Science Foundation, supporting science, technology, engineering, and math in Vermont colleges and businesses, and encouraging young Vermonters to seek careers in science. Additional funding provided by and from viewers like you. Thank you.